Hey everyone, just had some questions about how to solve stoichiometry problems, so I wanted to make this quick video to go over it with everyone so that we can talk about it. I'm going to try and finish this video within 15 minutes so that YouTube will let me upload it. So let's go. Okay, in this video, by the end of it, you should be able to identify the different types of stoichiometry problems, explain how to set up a solution for each type of stoichiometry problem, and solve the various types of stoichiometry problems. So there are 4 types of stoichiometry problems that you'll see in this unit. First is mole-to-mole conversions. I'm not going to show you an example of that in this video. That you should be able to see in activity 4. The second type is mole to mass. Third is mass to mole. And fourth is mass to mass. These types just tell you what you're starting with and what you're given, and then what you need to find at the end. Stoichiometry problems are a very important skill to master because you will see this throughout the rest of the course in future units. These problems also require you to have a lot of skills mastered already, right? You need to be able to balance chemical equations, identify types of reactions, and predict their products. You have to know about moles, molar mass, and molar ratios. So, with that being said, this is a big consolidation of skills. So I want to take it step by step. First, I think we should look at a mole to mass problem, which is when we're starting with moles being what we're given, and we're trying to find a mass. So I've already written the equations in these examples to save time. So the first question we'll look at is, what mass of zinc chloride can be produced by reacting 5 moles of HCl with excess zinc? Pay attention to the word excess. In stoichiometry problems, we are not concerned with a limiting reagent yet. That's a future lesson. This is just us saying, okay, let's assume that it reacts completely. So look for the word excess or completely reacts. So we're starting with, we know we have 5 moles of hydrochloric acid, and we're asked for a mass of zinc chloride. So that tells me that this is a moles to mass problem. So the first step in solving a stoichiometry problem is always writing your equation and balancing it, in the event that you have not already been provided a balanced equation, because you might be. But if you haven't, you need to write the equation and balance it. I'm not going to go over that in this video. The next step is to figure out what we are given and what is unknown. So we're given the moles of hydrochloric acid. We're told that's 5 moles. And we want to find the mass of zinc chloride. So the first thing, we know that we have 5 moles of hydrochloric acid. And then I want to look to my coefficients in front of the balanced equation to find the molar ratio of zinc chloride and hydrochloric acid. So this is where I think we were getting tripped up, because a lot of people were confused about how to set this up. It always comes down to what moles you have and what moles you want to find. What I mean by that is, if we have 5 moles of hydrochloric acid, we have to set up our molar ratio so that the moles of hydrochloric acid cancel out. So if we're comparing zinc chloride and hydrochloric acid, then we need to look at these coefficients. If there's no coefficient here, we know that's 1. So we have 1 mole of zinc chloride and 2 moles of hydrochloric acid. We know this makes sense because in this balanced equation, this is the same as saying, if you have 2 moles of hydrochloric acid, for every 2 moles of hydrochloric acid that go into this reaction and react completely, you'll produce 1 mole of zinc chloride. So that's how we can set that up. So 5 moles of hydrochloric acid is what we're told, and then we've set up our conversion factor for our molar ratio, 1 mole of zinc chloride per every 2 moles of HCl, right? And then the moles of HCl cancel out, That's how you know you set it up correctly. If the moles of what you already have cancel out to give you the moles of what you don't have as your unit, that's how you know it's correct. So this ends up being 5/2 moles of zinc chloride or 2.5 moles of zinc chloride. Then we are told, okay, we have moles now, so what are we going to do with the mass? How are we going to find that? So to find that, we're going to need to use our equation, moles equals mass over molar mass, and that's just how I like to write it out. And we want to find mass, so we have to rearrange this equation. I'm just going to change colors to make it super clear. We can rearrange the equation and find mass. We can isolate mass by multiplying both sides of the equation by the molar mass, because then those will cancel out. What you end up with is mass being equal to moles times molar mass. For that, you will get 2.5 moles of zinc chloride times the molar mass. You will have to look this up yourselves, but the molar mass of zinc chloride, 136.286 grams per mole. And then, right, we can always pay attention to our units to make sure it's correct. The moles will cancel out because moles is in the numerator here, as in moles are on the top over an imaginary denominator of 1, and then moles are in the denominator of grams per mole here. So the moles cancel out, giving us only grams. So 2.5 moles times 136.286 grams will give you 340.715 grams of zinc chloride. And I like us to round to 2 decimal places. I don't like to round until the very end. And this gives us a final answer of 340.72 grams. So what this means is, if we react 5 moles of hydrochloric acid with excess zinc, meaning we're assuming that the reagents are not limiting, then you will produce 340.72 grams of zinc chloride. So I'm going to leave it at that for this video, and then I'm going to go over the next 2 types of stoichiometry problems in another video. And this is just so I can make sure that I'm under the time limit for YouTube so that it will let me upload with no problems. So if you feel confident about stoichiometry problems, of course you don't have to watch these. This is just, an extra resource because I want to make sure everyone understands.